We've covered a question like this before. Still, I'm going to leave that up there for a little bit so that you can take the information in. We have the comparison of the length being 13 meters more than the width. So in my drawing, here's my width, whereas my length is 13 meters more. Not that it's 13 or that 13 is greater than some other number, but that we have added 13 meters to the width to get the length. We know that area is length times width for a rectangle. Filling in the 1,290 for the square meters that the area is equal to, and length times width, or width times length. I'm not bothering with rewriting the formula here. I don't see anything in the original formula that is squared that would connect to other pieces of the lesson. So instead, when I distribute W, now I'm going to see, sorry, that was supposed to be a 13. Now I'm going to see something that is squared. Remember leaving it in this factored form on the right side here on this line. Since it's not equal to 0, that's useless. I do have a 1w squared, but I don't have an even number, so if I can avoid completing the square, I will do that. So I'm going to get in standard form. And it might be possible to factor this, but given the size of the number 1,290, I don't know if it would be something where we could find a factor pair that multiplies to negative 1290 and adds to 13. Is that something we could find quickly? Is there even such a pair? Or is our solution here going to be something that has a decimal approximation, in which case we probably wouldn't have been able to factor anyway? So I'm going to go with the quadratic formula. And identifying my coefficients here. Watching the fact that there was subtraction here is making C a negative. And to get a little more room here, going to erase that. A reminder of the formula, but this time our variable is W, not X. So got to have W equals. And so we've got negative 13 plus or minus 13 squared minus 4 times A times negative 1390, 1290, sorry about that, all over 2 times A, 2 times 1. Doesn't hurt to figure out the 2 times the 1 down there, but our main goal is working out what we have underneath the square root and square, then multiply, then subtract, or in this case we're going to wind up adding. I squared the 13 to get 169. If I multiplied all that, I'd get a negative, but then I'd be subtracting a negative. So counting the fact that there are two and even number of negative signs, so to speak, I know I'm going to be adding, and 4 times 1290 is 5160. So adding the 169 to that, I get 5,329, which turns out to be a perfect square. (73) squared is 5,329. So square root of 5,329, that'll be 73. Split that up into the two cases of subtracting and adding, since we completely got rid of the square root. And one of them would give me a ridiculous answer of negative 43. Since the area is in square meters, and we have our comparison of length to width being that the length is 13 meters more, then negative 43 meters for the width makes no sense. So I'm going to reject that. And go over to the addition case of negative 13 plus 73 all over 2. And that's going to give me 60 over 2, or 30. That would be in meters. Area is in square meters. The length and the width are in meters. And so the length being 13 meters more than that, 30 plus 13 would give us 43 meters. If I multiply those out, length times width, that should give me the 1,290. So I'm checking that real quick. And yes, 30 times 43, that really is 1,290. And so those two parts there we need in the answer, that the length is 43 meters and that our width is 30 meters. And that does it for that question.